Alright, angle measure. And let's see. First thing we're going to talk about is array. Is a part of a line. Alright, array is a part of a line with a beginning at an endpoint and extending forever. In the other direction. Alright, so if you got a endpoint, alright, here's the symbol for array. It's just a little line with an arrow on it. When you're describing array, let's see, naming array, you always start with the letter that represents this is called an endpoint of array. Array begins at its endpoint. Okay? So if we were to name this ray, we would have to name it ray AB. We could also name it ray AC.
Mr. Holzenbach?
Yes?
I can't see your screen.
You can't see my screen? Who is this?
It's just white.
Yeah, it's completely blank.
Let's see. Sharing. What if I stop share? Share screen. Is that better?
Yeah.
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 Alright. Oh, where was I? When you're naming array, you have to, the first letter that you use in naming the array has to be the beginning of the ray. Okay? You've got this black ray right here, ray AB. Starts at A, goes through B, and it never ends. Same ray, starts at A, goes through C, never ends. Those are both the same ray, so you can name them either of those. There's another ray in this picture. There's a ray that can start at point B and go through C indefinitely. Alright? And if you were to name that ray, it would have to be named ray. That's ray BC. Does that make sense? So ray BC starts at B, goes through C forever. Ray AC or ray AB starts at point A and goes through B or through C forever. Opposite rays. Yes. Well, I'm not sure I understand your question. Opposite rays. Okay, they're just what they say they are. They share an endpoint. Okay, so look, if we were to take, we got ray AB right here, agreed? If we extend this thing and we go down this direction and we put point D on it, alright, then in this case ray AB and ray AD, you see ray AD? Ray AD starts at A, goes through D forever. Ray AB starts at A, goes through B forever. You see how they go in opposite directions of each other and share the same endpoint A? So we're going to say that rays AD and AB are opposite rays. Opposite rays, they have the same endpoints and they are collinear. That's real important. The collinear part, that's real important. They got to be on the same line. Because you'll see a quiz question that looks something like this. Alright, and you could be asked, are rays AE and AB opposite rays? Are rays AB and AE opposite rays? Well, they have the same endpoint, but they're not collinear, are they? They're not on the same line, so they are not opposite rays. Got it? Alright. Where'd all that come from? Man.
Can you go back up? I didn't get to finish the note.
Sure. It's gonna be on YouTube. It'll be posted on YouTube later, so unfortunately you'll have to go there and get it.
Okay.
Okay? You're welcome. An angle. Is formed by two non-collinear rays. Alright, so if we got a ray right here, and that's AB, and another ray right here, which is ray AC, you got two rays, same endpoint, they're non-collinear, so they form an angle. Okay? We're going to say that AB and AC, those are called sides of the angle. Alright, the rays that make up the angle are the sides. Point A is called the vertex. There's the vertex of the angle. This angle has an interior. And all of this region out here, that's called the exterior. And when naming an angle, the vertex is always the middle letter. Now, when you've got just one angle, there's only one angle in this picture, isn't there? So you can name this angle two ways. Since there's only one angle in here, you can name this angle A. If you were going to name it, you're only going to use one letter. You use the vertex. And when you're talking about angle A here, we know that we're talking about this angle right here. The other way to name an angle, and when there's more than one angle sharing a vertex, you have to use three letters. This angle could also be named angle BAC. And the third way you can name this angle is angle CAB.
Teachers, at this time, please hold your student for 6-day count. Again, please hold your students for a 6-day count. Thank you.
Alright, so you can name this angle by starting at B, going down to A, and then to C. Agreed? You could also name this angle by starting at point C, you go to point A, you stop, you turn, you go to point B. Okay? Your vertex is always the middle letter. Clear? Alright, so now let's look at when you've got multiple angles sharing the same vertex. Alright, so just looking at that diagram up there, can anybody give me a name for angle 1? Another name for angle 1? Yep. Angle ABC, good. What's another name for angle 1? CBA, good. Do you see why you can't call angle 1 angle B right now? You see why you can't call any of those angles angle B? Because B is used for, there's 1, 2, 3, 4, 5, there's 6 angles in that picture, okay? And angle B is the vertex for all of those. What's another name for angle 2? Speak up, let's go. CBD, good. What's another name for angle 3? DBE or EBD, right? Now, do you guys see, you see the 3 little angles, don't you? I'm thinking everybody sees those. Do you see this angle? Do you see angle CBE? You see it? Alright. It's a combination of angle 2 and angle 3, isn't it? And do you see angle ABD? Alright, that's another angle in that picture. Angle ABD. But it's hard to write with that big old fat marker. You see it? You see the last angle in this picture? What's the last angle in this picture? What's the third, fourth, fifth, the sixth angle? ABE, good. The big one on the outside, right? Right here. ABE. So there's all your different angles in that picture. They all use vertex B, or they all share vertex B. So you have to be careful when you're naming the angles. Clear? Good, 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 good. All right, let's talk about a right angle. What's the degree measure of a right angle? Anybody remember? 90 degrees. So right angle equals 90 degrees. Here's a picture of a right angle. And this symbol right down in here, that means 90 degrees. How about an acute angle? That's less than 90 degrees, right? And an acute angle would look anything like, here's an acute angle. Here's a acuter angle. Right? Anything less than 90 degrees. And then we've got obtuse angles. And an obtuse angle is greater than 90 and it's less than 180. Greater than 90 and less than 180. So we're going to say 90 is less than the angle, and the angle is less than 180 in degrees. So obtuse angles look like, here's one that's just a little bit bigger than 90 degrees. And then here's one that's a lot bigger than 90 degrees. Okay, any of these. Those are all obtuse angles. Greater than 90, less than 180. And then while we're here, let's just talk about a straight angle. And that's equal to 180 degrees. That's just a straight line, okay? A straight line actually has an angle measure. This angle measure right here is 180 degrees. Everybody doing all right so far? Anybody confused or have any questions? Yes, sir.
This has all your e-learners, right?
Yes. Everybody's accounted for, just except for one student.
Is that a live kid or an online kid?
I think it was Ben, right?
It's Kayla.
She's not coming to school. She's moving to Texas. And I was talking to her this weekend. She said she's not coming to school at all.
Kayla Bowles is the one that's unaccounted for, and she's supposedly moving to Texas.
Okay. Thank you.
Okay, a couple more things to talk about. We're just going to go ahead and we're real close to being finished with this section, so we're just going to finish it right now here. Let's talk about an angle bisector. Angle bisector is a ray that divides an angle into two congruent angles. An angle bisector is a ray that divides an angle into two congruent angles. Bisector, it bisects an angle, it splits it in half. So if you've got, let's say you've got this angle right here, angle ABC, and you're told that ray BD is an angle bisector. If ray BD is an angle bisector, then it splits angle ABC in half. Alright? These little arc marks, those little arcs, red arcs, one red arc in angle ABD and one red arc in angle DBC, means that angle ABD is congruent to angle DBC. If this measure right here is 40 degrees, then this measure right here is also 40 degrees. And if that's the case, then what would the, watch, you see this lowercase cursive m right here? That means the measure of angle ABC would be equal to what? The measure of angle ABC. Yeah, it's the sum of the two angles, and what would that be? 80 degrees. Very good. Kind of like the segments that we did last week, when you had to add two segments up to get the length of the full segment. Your angles have the same concept. Now, if you're told that BD is the angle bisector, well, then you know that these two angles are congruent. But you can have a case where it's not technically a bisector. Let's say in this case, you've got we got this picture going on here. Well, let me undo that. Don't draw that one. Just scratch that off. Let me get it a little more clear. Let's do this. Alright, in the figure, ray KJ and ray KM are opposite rays. KN bisects JKL. So KN bisects JKL. So let's see, where's K to N bisects JKL? Alright, so look, if K through N bisects J to K to L, right? Then isn't this angle the same as this angle? See it? Angle JKN. Angle JKN is 8x minus 13. So this angle in here, JKN, is 8x minus 13. And the measure of angle NKL, N to K to L, 6x plus 11. You need to find the measure of angle JKN. Alright, so if K to N is a bisector of JKL, we said that these two angles are equal to each other. So if they're equal to each other, we're going to set them equal to each other in an equation. We're going to say that 6x plus 11 is equal to 8x minus 13. Because we're looking for this angle right here. We need JKN. And JKN is right here. And JKN, the measure of that angle, is equal to this 8x minus 13, right? But we need to know the value of x so that we can substitute it, so we can find that angle measure. Well, we're going to use the fact that these two angles are congruent. So we're going to subtract 6x from each side. We're going to get 11 is equal to 2x minus 13. Going to add 13. 24 is going to equal 2x. We're going to divide by 2. So 12 is equal to x. Your x in this equation is equal to 12. But that's not what they asked for, is it? So we got to substitute the measure of JKN. It's going to be equal to, that's your 8 times x, which is 12, minus 13. And what's 8 times 12? 96 minus 13. That's 83 degrees. 83 degrees. So do you see the blue angle? It's 83 degrees, right? Who can tell me the measure of the red angle? Good, 83 degrees. And who can tell me the measure of this black angle right here? Is it? How would you find the measure of the black angle?
Subtract the 2 degrees out of 180.
Yeah, 180 minus the two other angles, right? Because MKJ, that was a straight line. Those points were collinear. So if we take 180 minus 83 minus another 83, 83 and 83 is what's that? 166? So 180 minus 166, 14 degrees. So the black angle up here is 14 degrees. Y'all good with that? Oh, don't fall. Any questions on that assignment? Or not assignment. Thank you. Any questions on anything we talked about today? Okay, I know that was a lot of me talking, but at least what we did was we covered the whole section. So now I'm going to give you some practice to do. And it's going to be very important that you use all of this class time to complete 100% of the practice. Because you will have a homework assignment on the practice tonight. Alright? It will be on focus. You'll have to answer some questions about the homework. So make sure before you open that homework assignment that you've completed this workbook assignment. If you guys haven't picked up a workbook yet, you need to come in and pick up a workbook from the front office. Say again? Yeah. Can I finish what I'm doing? Alright, so today's practice, we're going to say, what's today? The 31st? What? What'd you say? I'm aware. Thank you, though, for correcting me. We're going to be on page 8 in the workbook. You're doing problems 1 through 17. Doing all of them. If you got any questions while you're doing them, make sure you see me. Or I guess you people at home email me. When you have finished these, all of these problems, on focus, under alerts, it'll say something like PAM2, HW2. There will be some questions from this assignment that I need you to answer tonight, outside of class. Alright, anybody, any Zoomers got any questions before I close this session out?
Nope. I don't have any.
Alright, guys. That's it for today. I'll talk to you guys tomorrow.